Problems in Fluids 3, number 9. A 2 centimeter thick block of soap floats in water with 1.5 centimeters of the bar submerged. If the block is moved to a tub full of bath oil, density 900 kilograms per cubic meter, how high on the side of the soap will the oil reach? Let's look at the mass of the water displaced. This mass will be the density of the water times the volume of the water. Since our measurements are in centimeters, we can keep the density in centimeters. So the density of water is 1 gram per cubic centimeter. The volume of water displaced is the area of the block times its depth, which is 1.5 centimeters. Now I have the mass, but I don't know the area of the block, but this is the quantities we know. Let's move the block to the oil. And let's look at the mass of the oil displaced. This is going to be very similar. I have d dot v. And so this is 0.9 grams per cubic centimeter. X will be the displacement in the water, how far up and down it's going to move in the oil once I put it there. And then again, I have the same area of the block. Now, think about what Archimedes' principle says. If this is the mass of the water displaced, and the block is floating, this must equal the mass of the block. Otherwise, the block would go sailing off into space. So if I multiply them by g, I have the force. But the buoyant force pushing up must equal the weight of the block. So subtracting both by g, the mass of the water displaced must equal the mass of the block. But similarly, for the very same reason, the mass of the oil displaced must equal the mass of the block. The very fact that the block is floating says that the force down is equal to the force up, and it's in equilibrium. So in both cases, I must have the mass of the block. So those two things are equal to the mass of the block. They must be equal to each other. So let's make them each equal to each other. I have 1 gram per cubic centimeter times the area times 1.5 centimeters is equal to 0.9 grams per cubic centimeter times x times the area. Both sides have the area, so that can get canceled out. I solve this for x, and I get 1.67 centimeters. Therefore, when the block sits in the oil, it will have a displacement on the edge here of 1.67 centimeters, which is greater than the 1.5 from water. Water is more dense than oil, so this is a very logical answer.